Now we have our seasonal index. What's the benefit of this seasonal index? We now can make a seasonal forecast. And how do we do that? First of all, we create a forecast for all the considered periods. For example, we create a forecast of the average demand of the next year. And once we have this forecast for the whole year, we break it down to the individual periods and we multiply the seasonal index of the period with the average demand for all the periods. Now let's assume, in extension of the previous example, that now in the previous example, the the actual demand was 400 units for 1 year, for year number 3. Now let's say we created a new forecast for year number 4, and in this forecast we expect a demand of 420 units for the whole year. Now we divide this by 4 to get the average demand of a quarter, which is 105 units. 420 divided by 4 gives us 105 units as an average demand for the next year, for a quarter in the next year. And then we use our seasonal index and multiply this with the average quarterly demand, though therefore the expected first quarter demand is 1.28 times 105 equals 134.4 units. And this is repeated for all the other quarters. Now you see how much easier the forecast can be when we use the seasonal index. There's no need to create 4 individual forecasts, one for each quarter. We just create one forecast for the whole year. The next advantage, and the even bigger advantage, is, as you know from the previous lecture, an aggregated forecast is typically more precise than a disaggregated forecast. Though typically it is easier for us to make a good forecast for the whole year, this will be more precise than creating 4 individual forecasts for each quarter of the next year. So we increase our precision of the forecast, and we just apply these multiplication factors, these seasonal indices, to create a derived forecast for each quarter. That's a big simplification of our work, and it's even more precise. Although this is really a good benefit of the seasonal index. And of course, you see quarter 2 and quarter 4, they are approximately equal to the average demand, while in quarter 3 we are significantly lower than the average quarter, and quarter 1 is where we really sell a lot. This is significantly higher than the average quarterly demand. Here's an exercise where we apply these concepts for monthly forecasts, and your job is now to calculate the seasonal indices for each month. And recall, how can you check if your calculation of these 12 seasonal indices is actually correct? This exercise is based on the textbook Chapman et al. Exercise 8.12. Please do this as a self-study exercise. And once you're done with this exercise, we can try to apply the concepts of deseasonalizing demand in exercise number 3. Here the seasonal index is already given. The actual demand of the season is also given, and now you should calculate the deseasonalized demand. When your demand pattern shows seasonality, typically you know this because you work in the industry for a longer time, so you clearly know that there is seasonality present in your demand. Then always try to forecast the average demand. And based on this average demand, create your forecast by applying the seasonal indices, like we just did in the example. And when you use historical data to create your forecasts, this is often the sales data, the historical data is, of course, it happened in the specific season. So first of all, you need to de-seasonalize it before you use it for creating forecasts. This is what happened in exercise number 3. Though how to forecast with seasonality? Always use only de-seasonalized data for the forecast. Try to forecast the de-seasonalized demand and not the de-seasonal demand. Calculate seasonal forecasts by applying the seasonal index.